Dear students, welcome to our science episodes. Today's episode is about Unit 2, Lesson 1, Physical Properties of Electric Current. Physical Properties of the Electric Current. Can you imagine your life without electricity? I don't think so. Nowadays, we can't even think life without electricity. We use electricity every day. From the use of cell phones, televisions, light bulbs, and the internet, till the heating and cooling system in our homes, all are operating through electricity. But what is electric current? And how is electric current generated? Electric current is generated from electric power stations. They are away and away, very far from your house, by hundreds or thousands of kilometers. Let's recall together. All elements consist of atoms. An atom consists of a nucleus at the center. The nucleus contains positively charged particles called protons. If you can see, the protons are in red at the center of the nucleus. And neutral particles. These particles are called neutrons. The green parts, the green neutrons at the center. An atom also have negatively charged particles called electrons. These electrons are moving around the nucleus. Why? Due to the attraction force between protons and electrons. When electrons are generated from a metal element, an electric source, characterized by presence of weak attraction force between protons and electrons, this will result in an electromotive force, pumping electrons in one direction. So this means that an electric current or electricity is the flow of electrons in one direction in a metal conductor or a wire, creating an electric current. So again, what is electric current? It's the flow of electrons, not the protons, not the neutrons. It's the flow of electrons. Again, for an electric current to move in the conducting wires, the wires should have a potential difference, which means it has a positively charged unit or point and a negatively charged point, where the electrons will flow toward the positively charged point. Therefore, electric current is defined as the flow of electric negative charges. What are the electric negative charges? Electrons. Yes, electrons. Through a conducting material, a metal wire. Can you see the direction of the flow? This is the direction of the flow. From the positive to the negative inside the source, the battery, and then from the negative pole of the dry cell or the battery, again to the positive. This is a metal wire, a metal conductor in a closed electric circuit. Is this closed circuit? Yes, of course, it is. For electricity to flow, for the electric current to flow, the circuit has to be closed. If the circuit is open, the electric current will stop flowing. What is an electric circuit and what are its components? This is the electric circuit, and as I told you, the switch has to be on and the circuit has to be closed. If there is a gap or an open in the electric circuit, the electric current will stop flowing. This is the electric circuit where we used to draw it. It has symbols. So this is the symbol for the light bulb. This is the symbol for the switch. There is a wire connecting each part and the battery. These are the symbolic electric circuit. And as you see, the circuit has to be always closed for the electric current to flow. So what are the basic components of a simple electric circuit? It's a light bulb, switch, wire, and battery. Let's see together the components and the function of each part of the electric circuit. A lamp or a light bulb. This is an indicator for electric current presence. So if it is lit, the electric current is flowing, and if it is off, not showing any light, so the electric current is not flowing, and this is its symbol. So if you see a symbol like this in an electric circuit, this is a light bulb. A switch. A switch could be drawn like this or like this. This is an open switch, and this is a closed switch. And of course, its job is to close and open the circuit. A wire. A wire is just a straight line connecting all parts of electric circuit. And of course, it has to be a metal, a conductor, and it's used for the flow of the electric current across the electric circuit. The cell, or sometimes we call it the battery, it's the source of electrons. It has a negative and a positive pole. It could be one battery or more than one battery in a single circuit. Again, it has a negative pole and a positive pole. The battery is the source of electrons. What are the physical properties of electric current? Current intensity. Number 2, the potential difference. Number 3, the electromotive force. And number 4 is the electric resistance. Let's together discuss number 1, current intensity. Intensity means the quantity of electricity flowing. So if you can see here, this is a current with a higher intensity because the quantity of electrons are more than this one. This, of course, has lower intensity. And it's the quantity in coulomb, or the electric charges flowing through the cross-section of a conductor in 1 second only. So the amount or the quantity of electricity or electric charge flowing through the conductor in 1 second, we call it current intensity. This is the formula or the law to calculate current intensity. Current intensity is given the symbol I. It's the quantity of charge given the symbol Q over or divided by the time in seconds given the symbol T. This is the formula or the law. So current intensity equal quantity of charge divided by time. Measuring units. Current intensity is measured in amperes. The quantity of the charge is measured in coulomb. And the time is measured in seconds. That's why when we want to define the current intensity, let me give you a tip here. Know the rule. Study by heart this rule. Intensity equal quantity of charge over time. And then you can get the definition from this formula. If I want to get the definition from the formula, I will say that current intensity is the quantity of charges flowing in a metal conductor in 1 second. So from the formula, you can get the definition. And you have to know the measuring units for each item. Current intensity in ampere, quantity of charge in coulomb, and time in seconds. But what is ampere? It is the electric current intensity passing through a circuit, the whole circuit, when the charge of 1 coulomb passes through a given cross-section in 1 second. So we are measuring the electrical current intensity not in a given cross-section, but through the whole circuit, when only 1 coulomb will pass through a given cross-section in only 1 second. And ampere is the coulomb per second. But what is the coulomb? It's the measuring unit for the quantity of charge. So basically, it is the charge transferred by a constant current of intensity 1 ampere in 1 second. So it is the charges, the flow of charges by 1 second, but by a constant current of intensity 1 ampere. So if we reverse this law or this formula, so coulomb is ampere times second. Time for questions. What's meant by the electric current intensity passing through a conductor is 1.5 amperes. This means that the quantity of electric charge that passes through a conductor in 1 second equals 1.5 coulomb. What is meant by the quantity of electric charge that passes through a conductor in 1 second equals 5 coulomb? Yes, it means the intensity measured in amperes equal, this is the law, this is the formula we discussed before, equal quantity of charges in coulomb divided by time in seconds. So intensity equal 5 over 1, this is the quantity in coulomb, and 1 is 1 second, equal 5 amperes. This means that the current intensity passing through a conductor is equal to 5 amperes. Calculate the current intensity passing through a cross-section due to the flow of 5,400 coulombs for 5 minutes. Now we have the quantity, 5,400 coulombs, and the time, 5 minutes. First of all, we have to convert the time because in the formula, we are dealing with time in seconds, not in minutes. So first of all, we are going to calculate the time. Time is 5 minutes times 60 seconds. It will give 300 seconds. And then the formula is I equal Q over T, or intensity equal quantity over time. This means that the intensity will be 5,400 coulomb over or divided by 300 seconds, and the answer is going to be 18 amperes. Problem number 2. If a quantity of electricity of 12 coulombs passes through a cross-section of a conductor in 3 seconds, what is the intensity of the current passing through that conductor? Again, the formula is I equal Q over T, or intensity equal quantity over time. Therefore, the intensity will be equal to 12 divided by 3 equal 4 amperes. So, how can we measure the current intensity? What do you think? It's by a meter. The device is called a meter. And you can see here an old-fashioned one and a new digital one. We use this device to measure the electric current intensity in an electric circuit. The symbol is A, a circle, and a capital A inside this circle with a positive and a negative poles. It's connected to the circuit in series, where the positive pole of the ammeter is connected to the positive pole of the battery or the dry cell, and the negative pole of the ammeter is connected to the negative pole of the dry cell. Dear students, thank you for watching and wishing you the best of luck.